So today we're going over 7.5 part 2, evaluating and simplifying expressions containing rational expression. This builds off of what you learned yesterday. It's just going to be more numbers. So let's recall from yesterday you had the square root symbol, and recall that the radical symbol is used to indicate roots. Now remember, the standard root is only based on pairs. But now we can add an index. For example, the index is a small number to the left of the radical symbol that tells which root to take. So in the standard radical form, it's a 2. If it has an index, it has a different type of root. Like, for example, 3. We have the cube root of 8. That's how you read that third index. It's going to equal 2. How do you know that's going to be the cube root? Because 2 times 2 times 2. So 2 times itself 3 times is going to give us 8. Now, if you guys notice, based on the factor tree, yesterday we would do 2, 4, 2, and 2. And based on yesterday, we would take pairs because it was the standard square root. But now, since we have the index of 3, instead of looking for pairs, we're looking for triplets. So we would take out one of the numbers from that triplet. That's why the answer for this one would be 2. So we have the definition of b to the power of 1 over n. So a number raised to the power of 1 over n is equal to the nth root of that number. So 3 to the half is the square root of 3. 5 to the 1 over 4th power is the 4th root of 5. And 2 to the 1/7 power is 7 to the power is the 7th root of 2. So if b is greater than 1 and n is an integer where n is greater or equal to 2, then b is 1 over n. The n would be the index. So we went over how you have, let's say, 24 to the 1/4 power. We went over how to write it like this. Now we're going over how to solve them. Now, for the last test, we did have how to write it and how to solve it, but we used numbers that were only based on the notes and only based on the homeworks. Now here you guys are going to be able to solve for those roots, even if we haven't seen those numbers before. So a fractional exponent can have a numerator other than 1, as in the expression b to the 2/3 power. You can write the exponent as a product of 2 in 2 different ways. This is what we did a few chapters ago. We would write it as the cube root of b raised to the 2nd power, or you can also write it at b to the 2nd power, and then you take the cube root. It's the exact same thing, and either one is correct. It's just whether you square first or you square last, or whether you take the cube root first or you take the cube root last. It won't make a difference. Now, sometimes it'll be a lot easier to do one or the other. If we have, for example, 27 2 over 3, I think it's a lot easier to take the cube root first and then square, because the cube root of 27 is 9. So the cube root is 9, and I think squaring 9 is a lot easier. So I get 81. Now, if I were to square 27 times 27 and then take the cube root, I will still get 81. I think sometimes it's easier to do one or the other. It just depends on the type of problem you have. They just wanted to rewrite the expression. I'm going to rewrite it both ways. I'm not asking you guys to solve it, just rewriting it. So this one's going to be rewritten as the cube root of 343. Now, because it has a 1 at the top, we don't have to write anything to the 1st power. Though if you do, that is not wrong. It will not be marked wrong. It's just anything to the 1st power is itself. So we'll be left with the the cube root of 343. This will be your final answer, fully simplified, but this is also an acceptable answer. Now, for b to the 1 over n power is just going to be the nth root of b inside. Again, anything to the power of 1 and it's itself. If you happen to write the power of 1, it's fine. Just, if you don't, it's also okay. Both are completely acceptable answers. Now we have the definition of f to the power of m over n. So in words, we would say a number raised to the power of m over n is equal to the nth root of that number raised to the nth power. So like we did earlier with root 27, the cube root of 27. 8 to the power of 2/3, we're going to get the cube root of 8 and then square it. That's going to be a lot easier. Now, if you square 84 and then take the cube root, you're going to get the same answer. Right here we have the expression. In this first one, they took the cube root first. In the second one, they squared first. They still got 4 to be the answer. So if b is greater than 1 and m and n are integers, where m is greater than 1 and n is greater than 2, then you can write it either way. This is one way that we wrote it, and this is the other way that we have written it too. So they want us to simplify this expression. In this one, they want us to fully simplify, not just rewrite. I am going to rewrite it though to just see. It makes it easier to see visually how many pairs or how many numbers you need to find. They're asking for a 4. So it's the 4th root of 81. Now out of the top of my head, this isn't a common number, so I know it, but I'm going to show you guys how to solve it. If we do the factored tree, I can take out a 3, for example, and that's going to be 27. I can take out a 3 again and a 9. I can divide that by 3 and I get 3 and 3. Since we're looking for 4 of the same kind of number, you can think of card games, 4 of a kind. In this case, it's 4 because of the 4. Maybe 3, maybe 5, depending on the number. We have 1, 2, 3, 4 of the same number. Since we have 4 of the same numbers and it's an index of 4, our answer is just going to be 3. The 4th root of 81 is 3. All right, so let's do A and B together. Let's start with 16 to the power of 3 over 4. Now, I'm going to rewrite it like this. I just like seeing visually what each one means, even though I know what the fraction means. Now, they want the 4th root of 16, or we can cube 16 first. If you write it like this, is also okay. You guys can choose which way to do it. Now, because 16 is even number and it is actually a perfect root, I'm going to try to find the 4th root first. I think that's going to be a little easier for me. So I'm going to do 2 and 8, 2 and 4, 2 and 2. So I have 4 2's, which is what the index is telling us that it would be the 4th root. So I'm going to end up with 2 to the 3rd power. That's going to be 2 times 2 times 2. That's 4 times 2. So our final answer is actually going to be 8 for A. Now, if we do 16 times 16 times 16, we're going to get a number. And if we find the 4th root of that number, it's going to give us 8. In this case, I thought it was easier to take the 4th root first. A lot of the times, that's going to be the case when you have to square by a big number like 3, 4, 5 at the end. It's just good to know. And then for B, guys, just as a rule of thumb, anything, I'm going to rewrite it the other way as well. Anything to the 1 to the power of anything is just 1, and the square root of 1 is just 1. So it doesn't matter what fraction you have up there. If it's 1 and to whatever fraction you have as the exponent, the answer is always going to be 1. Because 1 times 1 times 1 times 1 times 1 is going to be 1, and the square root of 1 is just 1. Doesn't matter how many times you take it, it's still always going to be 1. So here they want us to take 27 to the power of 4 over 3. Now again, I'm going to write it both ways. I'm going to do the cube root of 27 to the 4th power, or 27 to the 4th power and take the cube root. I'm going to choose this way. I think it's a little bit easier because 27, we've done it before. We know what the cube root is, but I'm still going to work it out. You do 3 and 9, 3 and 3. Because the index has 3, we're looking for 3 of the same. Here we have them. So I have 3 to the 4th power. Now it's going to be 3 times 3 times 3 times 3, 9 times 9. So we're going to get 81 as our final answer for C. So they want 81 to the power of 5 over 4. So again, I'm going to write it both ways. You don't have to write it both ways. You can choose to do one or the other. All right, so 81 and then squared to the 5th power. Or you can also write 81 to the 5th power, the square root of 4. Again, just choose one. Either one is correct. I don't mind whichever you prefer. I always try and take the root first because it simplifies the number, and I prefer multiplying smaller numbers, but it's really up to what you prefer. So I'm going to go for this one again. So I want 4 because the index is 4. I'm going to try 3, 27, 3, 9, 3, 3. Again, we have 4 of the same, so we have 3. So it's going to now be 3 to the 5th power. So I can do 3 times 3 times 3 times 3 times 3. This is 9. I'm just going to rewrite the numbers. This is 27. This is 81. And then 81 times 3 is 243. There's multiple ways of getting to that answer. In this case, I just chose to multiply 1 3 at a time. So simplify all variables represents non-negative numbers. So they're asking for the 4th root of those variables. Now, I'm going to go ahead, and we know the index is 4, so we want 4 of a kind. I'm going to expand this so you guys see it. So those are the x's, and then so here we have the 4 x's and we have the 12 y's, right? The 4 x's are right here and the 12 y's are right here. Now you don't have to expand them in order to understand what's going on here, okay? This is just 2 different ways. I'm going to show you both ways of doing it. Notice how for the x, we do have 4 of a kind, so I can just take out an x as the answer. And for y, I have 1, 2, 3, right? 3 rows of 4s. So it would be y to the 3rd power. This would be your answer if you want to expand it. Now, you also know that we can rewrite this expression as x to the 4th over the 4th power and y to the 12 over the 4th power. This kind of has to do with the problem we did yesterday that was on yellow, that's just one singular lonely problem. And those are simplified expressions. Now, we can simplify that x to the power of 1 and y to the power of 3 because 4 divided by 4 is 1 and 12 divided by 4 is 3, which at the end in turn gives you the exact same thing. So you can do this type of problems 2 different ways. You can rewrite it into a fraction exponent and simplify the exponent like it is right here in the second way. Or you can do it the first way we did it, which is expanding all of those variables. Now, if you can just see how many pairs you have, how many of the same kind you have, and so on, without expanding it, by all means, go ahead and do it. I always either expand or rewrite it as a fraction in the exponent. A lot of times I prefer the fraction of the exponent because it takes a little bit less space on the paper, but it's whichever you prefer. At the end of the day, we get the exact same answer. So, since there's no more questions and this was part 2, we are done with the notes for 7.5. There is homework on Canvas, but this is it for today's notes.